eBPF is Superpowers for Linux. What JavaScript is to the browser, eBPF is for Linux and other operating systems now. I wrote my own job description, sent it to her, and said, this is what I'd like to do. And I guess the rest is kind of history. That's really why we say this is the superpower of eBPF, because it allows us to do things that weren't possible before.
Jesus, this thing is so well done. It looks like $1 million.
eBPF is really like this underlying technology. It allows us to do faster networking, deeper observability, better security, and telling that story of how this technology enables innovation on top of it. What's exciting to me about technology is because by building better building blocks, we can actually create a better world.
Bill Mulligan, community at Isovalent, working on Cilium and eBPF stuff, is probably the best person I could find to talk about eBPF. And you probably saw recently, or maybe not recently, it's been about 10 months since the documentary been released, his name next to that, so we're definitely going to talk about it. But before all of that, Bill, how are you doing today?
I'm doing really good. How are you?
Yeah, I'm doing great. I'm really hyped for this. eBPF is one of those things that really blew my mind the first time I saw it. Back then, I wasn't that interested in the Linux internals. And then this thing happens, and all of a sudden, all these opportunities open in front of me. And I felt there's feeling like a sudo, and then there's feeling like eBPF, a whole new level.
I was working at CNCF, the Cloud Native Computing Foundation, helping growing the worldwide cloud native community. And I was looking at other opportunities after I left CNCF. And one of them was my current boss, Liz Rice. She posted, hey, I'm looking for people to help me out and join my team and help grow Cilium and eBPF. And I heard about both projects before, and I knew that a couple people thought they were interesting, but I didn't really know what was really below the surface on either of them. But I knew that Liz was a really well-respected person in the community, and where she went, a lot of other people would also be looking too. So I messaged her, hey, I'd love to join your team. I wrote my own job description, sent it to her, and said, this is what I'd like to do. And I guess the rest is kind of history. And then I joined Isovalent, and I'd been around the cloud native industry for a while, but I remember the first couple of weeks there, where all of a sudden you're going from, these kind of Kubernetes cloud native concepts. Yeah, I know a pod, a replica set, all that stuff is. And suddenly you're with a bunch of kernel engineers, and they're all talking about diving into really deep C code. Oh, this is a really simple example. I just threw this together really quickly, and I have absolutely no idea what's going on in these team meetings. And I'm thinking to myself, okay, I thought I knew what I was doing, but this eBPF thing is a whole different level. So when I first joined Isovalent, it was definitely a steep learning curve because eBPF is such a low-level technology. But I think that's also what makes the technology exciting, is because it's something really deep in the weeds of Linux, and it has this really powerful opportunity to change what we're doing down there. I think what's cool is that it's making operating systems and low-level systems engineering exciting and innovative again. And so that's how I got into eBPF, and yeah, I'm excited about it now.
Love it. Especially loved a bit when you wrote your own job description. There are stories when people do this. Did you think, okay, this is going to look great in my biography when someone eventually writes it? It's going to sound like a really good trick. What were you thinking to do that?
So before CNCF, I was at a different company, and I'd actually written this job description. And I said, I wanted to pivot away. There I was actually doing sales, and I wanted to pivot more into community type stuff and growing that. So I actually had the job description already written, and it was something that I knew I wanted to do. And so when this opportunity with Isovalent came along, I basically took the old job description, replaced the old company with the new company and the new technologies. So I was like, hey, look at this thing I just wrote that I've actually had around 2 years. So I was just doing something I already knew I wanted to do, and just replacing the technology that I was doing.
Awesome. So you had the job ready. You just needed a company to actually implement that. That was so cool.
Exactly.
Question about the CNCF, because I started looking at CNCF and Kubernetes early on, version 1.2. I'm forgetting if it was 2016 at the first KubeCon that was in London. I just happened to be down the road from where I was working. And I got pulled into that, and I never managed to get out, frankly. How did you get into CNCF in the first place? And also, what was the experience of kind of seeing something grow so successful so quickly and just so massive? I've never seen anything like that before.
Yeah, I would say CNCF was also a bit of an accident. So like my background isn't in coding at all. I actually don't write any code previously or even now. I actually did my undergrad in biochemistry and my master's in social science. So when I was looking for a job after grad school, I was interested in AI because that's what I'd written my thesis on. And I got a job that was doing an AI platform on Kubernetes. And I was like, it has AI, let me do it. I have no clue what this Kubernetes thing is, but let's see. And so like the first day on my job, it's like Kubernetes 1.8, this really thick, like chunky Windows ThinkPad. And they're like, you're going to set up a Kubernetes cluster. I'd never seen the command line before, like never done anything. And it took me 8 hours, like going through like VirtualBox and like PuTTY, like trying to set up the cluster. But I set up a Kubernetes cluster in 8 hours, which is very laughable if you think about how fast you can spin them up now. And so that was like my introduction into Kubernetes and cloud native. And I went through a couple different startups doing different things. And when I said I wrote the job description that I wanted to have, I knew I was really excited about community building. I think this is really fun when you enable people to do what they're passionate about. I think that's the cool part about communities is like you're letting people do what they're excited about and you're helping them to do that, to create something cool together. And so I think it was quite fun, like going through these startups and seeing different parts. But then like when the opportunity came up at CNCF, this is actually another Twitter story. Somebody like posted on Twitter, hey, I'm hiring for my team. And I just submitted an application and then went through the interview process and I ended up being hired into CNCF. And it's because I showed that I was interested in like the open source community because I'd been involved in a couple different projects. I've been following a lot of different things. And that I was excited about helping something that was growing so fast continue its kind of exponential path.
Wow, a lot of serendipity in your story there. That is crazy. And also the ThinkPad, I like that story. I used to have one of those. They were very chunky and not only good for hacking things, but also for like defense. If you ever need to smack somebody with one of these, good as a tray as well. That's very cool.
Paperweight, book stop.
Yeah, they were bulky and indestructible. For those who haven't heard of that, we alluded to that quite a lot already, but if somebody doesn't know what eBPF can really do, can you explain simply why it's such a big deal? So
there's a couple different examples that we like to give, and so I'll walk through them like one at a time so that people can understand them. The super high level one that Brendan Gregg likes to say is eBPF is superpowers for Linux. So it enables us to do things that weren't possible before. And then going down one level from that, we like to say what JavaScript is to the browser, eBPF is for Linux and other operating systems now too. And so like to break down that analogy, if you think about what JavaScript brought to the browser is like suddenly you're going from these static web pages where you're just like consuming information into suddenly like you have a web page that's interactive. They have clickable elements. Things will change as you interact with the web page. And that's essentially what eBPF allows you to do to the Linux kernel too, is like suddenly you can make it interactive. You can add programs on the fly. You can add new functionality on the fly. You can change based on user input. And so it's like letting you change how things are happening on the fly to introduce new functionality and add programmability into it. And then going down one more level, I think it's what eBPF is allowing us to do is to massively speed up the innovation cycle in the Linux kernel. Because if you're not super familiar with like how the Linux kernel works, it's a 30-year-old technology. There's a lot of history behind how it's been built and what's been built into it. And it's deployed in literally billions of devices and servers and other things across the globe. So you need to have predictable innovation cycles that you don't break these billions of users, billions of devices. And so what that kind of does is it slows down how fast you can change things. And so that's, I think, why a lot of people started to see operating systems or Linux starting to be a little bit boring. It's if you want to bring a change to the Linux kernel, first you have to convince the whole like Linux kernel community that it's like good for everybody. And then you need to merge it into like upstream, which may take a year. And then it gets to long, like an LTS distribution that you're actually running in production. So you can have something from idea to actually getting it in production. It could be something like 5 years. That really slows down what's possible. And so suddenly with eBPF, what you're able to do is to add new functionality on the fly into the Linux kernel. So like the example Brendan Gregg likes to give is, so he wasn't Netflix, now he's at Intel. He's saying their customers are asking questions like, how does this functionality work? How is this affecting the performance of our systems? And rather than trying to implement something in the Linux kernel, recompiling it, reloading it, and doing all of that, what he's able to do now is write an eBPF program, install it like on the fly, answer the customer's questions before the end of the meeting. So suddenly, instead of this 5-year innovation cycle, you can suddenly get the data that you want in just minutes, like as fast as you can program the thing, load it into your system, and then find out the information. And so going from years down to days, weeks, or even months, like that's a totally different way of being able to innovate. And so I think that's why eBPF is making the whole Linux kernel, the operating system, exciting, is because it allows us to reprogram on the fly, to add new functionality, to enable to do things that weren't possible before. And that's really why we say this is the superpower of eBPF, because it allows us to do things that weren't possible before.
I like the layer cake approach to explaining this. Clearly, you've done this a bunch of times to different levels of technicality of people. A little footnote for anybody who hasn't heard of Brendan Gregg: if you ever type anything eBPF in Google, you're probably going to bump into either his blog or one of the talks. There is a bunch of books on performance. And what were the initial eBPF tools called?
Yeah, BCC, BPF trace.
Yeah, these were some of the original tools that played the role of teaching other people how to use eBPF. A big figure in the entire story. So, to summarize what you said to a 5-year-old software engineer is, if you wanted to modify or get anything into the kernel, you would either have to go into a 5-year cycle of trying to push that into the kernel, or you have to do some kind of patch and then hack it together and hopefully not break your kernels. And today you can do all of that more easily on the fly with eBPF, with some bumpers as well. I don't know, is it worth also mentioning like the security and the performance aspect of that?
Yeah, definitely. So those are the two ways. The other way that you can like kind of add new functionality to the Linux kernel is through kernel modules, but these are maybe more risky than having something accepted by upstream or going through eBPF, because it may crash or otherwise harm your system. And the operating system is the most important part, because if the operating system isn't working, nothing else is working. And so eBPF was trying to take the learnings from upstream, from what happened with kernel modules, and how can we essentially, if you're adding programmability into the core of the system in the OS, how can you also make that safe and performant too? Because those are two key things, especially when you're operating at that layer. So there's a couple different things that eBPF has that kind of ensures the safety and also the speed of the system too. And so really, I would say one of the key innovations for eBPF was the eBPF verifier. And so what the eBPF verifier does is, before the program is actually loaded into kernel space, it'll check to make sure that the program runs to completion, that it doesn't crash or otherwise harm the system, it's not accessing memory that it's not supposed to. And so this is really the part that like ensures the safety of the system, is the verifier. And the verifier is really the part that people, for the safety part, love, for just getting things done, hate. I know there's a lot of talks out there in commentary about how people hate the eBPF verifier because it slows them down, because it doesn't do things that might harm the system, right? And so it's annoying to not be able to do exactly what you want to, but you're still able to get a lot of things done and also ensure the safety of the system. And I think this is where a lot of the innovation in eBPF is, really ensuring the safety of the system. And then once you pass the verifier, then it's going to be compiled into machine-specific like bytecode, and that allows it to run as fast as natively compiled kernel code, right? So you have this really fast, efficient programming running in kernel space, so you don't have to deal with kind of like switching contexts between user space and kernel space, because that causes a lot of overhead too. So you have these really small, fast, flexible programs that you're able to install into the operating system without crashing or otherwise harming the operating system. So a lot of power, but also safeguards around that too. So you can deploy and use eBPF in a confident way.
And it's technically running inside of a mini VM, isn't it?
Yeah.
Which is another interesting choice. I'm picturing the initial conversations. You know, guys, I would like to put a VM into my kernel. That would go down interestingly, I think. There's also the built-in primitives that make things easy. ish and more efficient to aggregate things inside of the kernel before you have to push them to user space, right?
So you're talking about like the different eBPF libraries?
I'm talking about like maps and counters and stuff like that.
Yeah, so there's like the initial implementation of eBPF that was very bare bones. And over the 10 years since eBPF was first merged into the kernel, the community has added a lot of the things to make it easier to program what's happening with eBPF. One of the things is the eBPF maps. And so this allows us to efficiently share memory between user space and kernel space. So programs can share information across this boundary. Another example is like expanding the instruction set limit. So originally you were only able to have 4K instructions, and now the instruction limit has been lifted to 1 million. And you're also able to tail multiple eBPF programs together. So essentially going from one to the next. I think that's the exciting thing about eBPF is it's continuing to innovate and add these ways to make it easier to program and do what you want to. I think there's this idea that eBPF is this very limited thing because originally when it was designed, they didn't want to break the kernel. And so it had the limited instruction set. There wasn't like the maps. You couldn't tail multiple programs together. And there's like other limitations too. And bit by bit, they've taken off some of those limits and made it more flexible, more multi-purpose. And I think we've really seen the boundary of what's possible really expanded by eBPF. Actually, so Liz just released a blog post talking about how eBPF is now Turing complete. Not that's like the most important thing, but it's an interesting way of saying that, yes, it's a universal programming language. And the way that she shows that is she implements Conway's game of life in eBPF. And she does that by having wait and tailing multiple programs together. And it showing that, yes, you can program essentially anything that you want to in eBPF. Not saying that anything should be programmed in eBPF. There's limitations. There's better ways to implement things, but it's possible to do multiple different things. So yes, technically you could port Doom into eBPF. Now, whether you actually want to do that or not is a different question.
Well, that was exactly going to be my question. Does it run Doom yet?
My favorite one recently was somebody implemented Snake with BPF trace. So your favorite game from the Nokia phones is now available in eBPF. I was like, okay, we've made it now. We can play Snake in eBPF.
Well, love it. If Linux had press releases, you would be like, batteries included. Your favorite game from Nokia now available on your nearby community kernel. Sounds great. I'm going to ask you in a little bit about how it actually looks like in practice and how to get started today, because I suspect my knowledge from a couple of years ago is probably outdated. But I wanted to also point out that if you are only starting with eBPF, first of all, better late than never. Second of all, you're actually in for a massive treat, because back when I was looking at it a few years ago, all I had to do was a few blog posts from Brendan and, here's the source code, go read through that and figure out how to use that. Whereas now you actually have amazing resources, including that documentary on eBPF that is available on YouTube. And you can go spend half an hour and learn everything about the history of it in a very cinematic way. Jesus, this thing is so well done. It looks like $1 million. Tell us about it.
Yes, the eBPF documentary was probably one of the most fun projects that I've worked on in my career. So the initial idea, once again, started on Twitter. So if you haven't seen the team that behind it, Speakeasy Productions, they've actually done like a couple different documentaries on different technologies, on a couple different frameworks. And then the first one that really caught my attention was when they did a documentary on Kubernetes. And this is like a 2-part documentary talking about like the history of this and how it came together. And then after that, when I was working at CNCF, they also did a couple other documentaries like on Envoy and Prometheus. And I saw those movies coming out. And when I saw one of them coming out, I was like, oh, so great to see this one come out. Can't wait for the one on Cilium project. Just like as a joke, because I knew there wasn't going to be one on Cilium next. And Chris, who's the CTO of CNCF, was like, I don't think Cilium's ready yet, but it could be funny to do one on eBPF. And like any good thing, kicked off a conversation on Twitter, and that got the ball rolling. So we got in contact with the team at Speakeasy Productions, and they said, hey, if you can pull together the sponsors, we'd love to do the eBPF documentary. It's going to be a great story. The whole narrative arc, if you haven't seen it yet, I don't want to give too many spoilers, but I think it has the whole arc of a good story, from the build up, the defeat, coming back, like the whole community coming together, like it's a nice story. And yeah, it's cool to, I think, almost like 10 years on, pull back together like the original team that kind of brought it together. So like Daniel and Alexi and Brendan and David Miller, interviewing them and seeing like how they thought this thing came into be. And so it was cool to see like the arc of the story now that we know it's become such a powerful force in the industry too.
Yeah. And so if you're watching this on YouTube, you have my blessing. Go and watch that and then come back for the rest of the conversation, half an hour. It's mind-blowingly well done. And I really loved it. I actually learned quite a bit from it too. And you get to see the people and like their characters and way of speaking. And you just put so much more meat on the, proverbial bone here. Definitely a great idea. Do you have any other ones that you've been trying to kick off on Twitter that are incoming?
There's actually, as an offshoot of the eBPF documentary, we were also working on one about the story behind Isovalent, because the story of eBPF, Isovalent, and Cilium are all intertwined. And so taking some of what happened with eBPF and telling how that created Isovalent and where the company went from there. So that one should be coming soon. And then potentially, we've also kicked around the idea of doing one about Cilium, which should be quite fun. And then also doing like a part 2 to the eBPF one. Because I think the original one focused a lot on like how the technology first got merged into Linux kernel and came to be. And we were thinking about like doing a follow-up on like how has it changed the industry? What are the different things that it's done around networking, observability, security, tracing, monitoring. I think we just talked about the technology itself, but not all the technologies that it's enabling now. And I think there's a really great story there too, to talk about. eBPF is really like this underlying technology. It allows us to do faster network, deeper observability, better security, and telling that story of how this technology enables innovation on top of it. And it's like changing how platforms are built because it's adding this programmability into it. So we've tossed around the idea of that yet, but no concrete plans yet.
Awesome. We mentioned Brendan, and you threw around a few names. Maybe it would be helpful to give people a little bit more context, just a quick blurb of each of the people you mentioned from the documentary who really played a big role in getting eBPF to exist.
Yeah. So the two co-founders of eBPF are Daniel Borkman and Alexi. So at the time, Daniel was working at Red Hat, and Alexi was working at a startup called PlumGrid that actually went away. Like the idea of PlumGrid was being able to like redesign a network, and they needed a way to do that. And they wanted to have a way to insert bytecode into the kernel. And Alexi originally came along with this big way to rewrite things like through this huge PR at the kernel community. And of course, if you try to do that open source community is no way, not possible to do this, right? And
yeah.
But kind of the idea of making the kernel programmable was really interesting. And after that, other people started to see the idea, Daniel, and he started to work with Alexi. And they said that, hey, rather than trying to introduce this whole new thing into the kernel, a better way to do it is to take something that's already in there and make it incrementally better. So rather than creating like a new subsystem, why don't we improve an existing one? And that's where they landed on BPF. And so like BPF is the Berkeley Packet Filter. This is a way to do like packet filter. And so they started to add different things into that piece by piece to allow them to both improve BPF, what we now call classic BPF, and also extend the subsystem to make it more programmable and more flexible in what it's able to do. And so Daniel and Alexi like worked together to get the initial patch set in of what now became eBPF, and that's like spring 2014. And from there, they started building all the different pieces. And then Brendan was also involved there too. He wanted to do like system performance monitoring observability at Netflix, right? Because when you're streaming a lot of data, you really need to know how performant your systems are being. And so they started to work together, and Brendan started bringing in like the tracing angle, adding a new use case. So it's not just about networking, but it's also about tracing and observability too. And they all started like working together. Brendan went around and wrote the original books on it, the blog post, going out there and getting that work done. And there's a lot more characters. David Miller, for instance, was like the networking subsystem maintainer that merged the original patch set. And there's a lot of other people that I'm not mentioning or didn't have time to include in the documentary. But a lot of people came together to make this technology possible. And I think that's like the exciting thing about open source is one person had this idea over there. This other person's like, hey, I like that idea, but we need to change it slightly. Let's work together and let's build something that like neither of us could do alone. I think eBPF is this really cool story of like a group of friends all coming together, and they want to essentially make like low-level systems programming exciting again. And nobody think that would be exciting, right? But now we look like a decade on and we can see, wow, eBPF is really what makes exciting again. I think that's what's really cool, is this group of people coming together towards a common goal to improve how things are. And that's why I really like working in communities.
Linux, bringing people together. So that makes me think, for the sequel of the eBPF documentary, I'll give you the title. It's yours for free. Call it The Ultimate Trojan Horse. And then the subtitle goes, How One Person's Desire to Play Snake on Linux Kernel Took 10 years and hundreds of peers into the kernel. Yeah, this is such a good story. People will be probably learning that soon in computer science if they're not already doing that yet at university. Love it. And the fact that documentary exists now is just a net positive for human race, I believe. So well done on that. Awesome. And yeah, never quit Twitter. All right, so let's now shift gears a little bit into the let's make use of this thing mode. For somebody starting today, what does it look like in practice? Let's say you want to write a snake for eBPF. Where do you start?
Yeah, so the first place that I would recommend starting is eBPF.io. This is like the homepage of the community, and it has a lot of different resources on there. The place that I would start reading is like the What is eBPF page, and it walks you through what eBPF is and kind of like all the different components in a little bit more detail than we've talked about today. And it gives you a good idea and overview of what eBPF actually is. From there, a good place to go after that is obviously Wikipedia. Like any good things on the internet, eBPF has a Wikipedia page, and it dives a little bit more into the nuts and bolts about the different parts of eBPF and how they work. And then if you actually want to get into the actual programming, there's a couple different resources. So one, like we actually have a hands-on lab, like getting started with eBPF. This sets you up in a live system and essentially walks you through a hello world type of program. So you're like writing your first eBPF program. But if you want to get a little bit more hands-on than that, so Liz Rice has actually written 2 different books on eBPF. First, what is eBPF? And then the second one is learning eBPF. The first one is like a really short 60-page, essentially like telling you how to write your first eBPF programs. I think that's a really good like short overview. And then learning eBPF is like the actual semi-textbook type of thing that's actually diving more in detail, and that'll help you write your first programs. I think I really like the learning eBPF program because it's actually inspired somebody in the community that I know. They said, hey, I see that there's eBPF libraries for Go, for Python, for a couple other languages, but there's not one for Java yet. And I'm a Java developer. So I'm going to take the Learning eBPF book and try to re-implement all the different things that are in there in Java and write my own Java library for eBPF. And Johannes has like this whole series of blog posts about how he's able to write Java code to implement eBPF programs. He started out with Hello World, and he's taken it all the way to writing a firewall. And he actually just at eBPF Summit talked about how he used Java eBPF, or he wrote Java code that translates to eBPF to write a scheduler for Linux. So he's writing a Java scheduler for Linux using eBPF. And so you can see the whole kind of progression there. And it was cool for him to see the initial blogs, get excited about it, like get the book, want to re-implement some of the examples, and now creating his own scheduler. And so this is something that anybody can do. I'd recommend his blog post. You can see like the whole progression and the journey across that. And you can really go from not knowing anything about eBPF to writing your own scheduler. So that's a really good book for it too. And then shameless self-promotion here. I also wrote a book called Buzzing Across Space, the Illustrated Children's Guide to eBPF. And that's like the kind of kids version with some nice pictures in it too.
That's awesome. Where do we get that one?
You can also find that on eBPF.io.
Who runs eBPF.io?
This website is actually owned by Daniel. So when he originally co-founded eBPF, he bought the domain and has been using it since. And then I work with Daniel now to maintain the website as a community resource for people to use.
So is that affiliated with Cilium or completely independent?
It's completely independent. It's just Daniel and I merging changes into the website as people suggest them. So it has other resources too, like it has an eBPF landscape of all the different projects that are happening. So you can see what people are building with eBPF, also different use cases of eBPF. And it's also, we've worked a lot to help internationalize it. So I think it's translated into 9 different languages now too. And those are all done by like the community. So if you'd like to work on translation, reach out to me and I'm happy to help you with that too.
There you go. You name dropped the eBPF Summit. Can you talk a little bit about where do eBPF people hang out, what kind of conferences to find them at, and I guess why people should come to the next eBPF Summit?
Yeah, so I really like eBPF Summit because it highlights all the biggest developments in eBPF over the past year. So some of the keynotes that we had was like one, Johannes talking about like how he used Java to write a Linux scheduler. And then we also had Thomas talking about the future of eBPF, where it's going. I'm sure we'll talk about that later in our conversation. We had Shweta from Netflix talking about how Netflix is using eBPF and how it's changing how they're doing systems observability. Yeah, and I think eBPF Summit is cool because you're seeing a lot of the different cutting edge use cases that are coming out of the eBPF ecosystem. And we really see it as a way for people to come together and talk about what are the exciting use cases for eBPF. It's like people who are writing their own programs, like how do you do it? What are the different use cases and how are we going to do it better in the next year? And then like from there, if you're talking about like different conferences, I think you can either go like up or like more and deeper. And so if you're going to go deeper, actually there's Linux Plumbers Conference. And so this is where like Daniel and Alexi are going to get together with other contributors to the eBPF subsystem and talk about what kind of developments do we need to have, like where should we go in the next year, what's the technical roadmap for eBPF, and talking about that. So that's Linux Plumbers Conference.
Is that open to everybody, or do you need like an invitation for the Linux Plumbers?
I think Linux Plumbers Conference is open to everyone, but there's also BPF Conf, which is invite only, and that's just the maintainers. So those are like the low level, what's the technical roadmap for eBPF and where it's going. And then going higher level, I'm also co-chairing like Cilium and eBPF Day, which is co-located with KubeCon. And that's like talking about like the like higher level use cases, how our projects, like for example, in cloud native, leveraging eBPF to accomplish things that they weren't able to before.
Let's talk about Cilium for a little bit now. From where I sit, it looks like Cilium is probably the most recognizable company that kind of emerged from the eBPF story. I know that there are major cloud providers that use Cilium as default now. I know that a lot of people I speak to at least tried Cilium and use it for various things, including like the security stuff and observability. How well are you guys doing? And what is Cilium all about?
Yeah, so I guess there's one clarification here. So Cilium is just an open source project. So it's owned by the CNCF. It's not actually a company. It's free for anyone to contribute to. We like to have contributors. And we have contributors from, what is it, like 300 companies now, I think. So I'm a maintainer of the Cilium project and I'm employed by Isovalent, but it does 2 separate things. Yeah, it's been crazy for me to track the growth of the Cilium project in the time that I've been at Isovalent. When I got there, it had been chosen as the data plane for Google, for GKE, and then also for EKS Anywhere, so Amazon. And then since that time, we've really like seen the explosion of the ecosystem around Cilium. And I think that's been amazing. It's now the default also for Microsoft and for basically all the other cloud providers out there too. It's big. Cilium has really become kind of like the standard cloud native networking layer. People are using it like in every single industry. If you check out Cilium.io, we have vertical use cases pages where we're talking about different case studies of how Cilium is being used in different industries. And then a broad spectrum of different things. And I think what's cool is seeing the growth of the project. So originally Cilium began as just a CNI, providing the container networking in a Kubernetes cluster. And since then, it's grown both down the stack and up the stack. So doing things like auto announcements, BGP, integrating into really data center fabric, and then also going up the stack towards more like layer 7 stuff. So doing things like service mesh, gateway API, ingress. So really managing like your whole networking stack as one layer, right? And so having one consistent way to control your network in a cloud native fashion. And then the project has also expanded beyond just networking to also include observability with Hubble, and then also the security with Tetragon too. And it's been cool to see how the project has like grown in the couple of years that I've been working on it. And it's been amazing to see the growth of the project. And it's really become Cilium is everywhere. The one point that really came home to me about, oh wow, Cilium has really made it now, is when I was at KubeCon and I was working at the Cilium booth in one of the events. And I was standing there. And somebody came up to me and they said, I really need Cilium. What's Cilium? Just like the type of, this is the technology that I'm supposed to have, but what is it? You need to tell me so that I can have what I'm supposed to need. And I was like, okay, I think this is the peak of the hype cycle right now.
Wow. Yeah, when people come and ask you for that and then ask questions about what it is, that I guess is how you know you've made it. What does Cilium actually mean? At this rate, I'm too afraid to ask, but I'm going to ask anyway.
So Cilium is actually a biological term, which is like funny coming from like my background as biochemist. And it's the plural of cilia. And cilia is like these air structures that kind of like wave around and do a lot of like sensory things in your body. You have a lot of receptors and stuff. The idea was like it's networked, this like web going out and connecting everything and sensing everything, and like playing off of that. And so actually, if you ever get to see the original like Cilium logo, it's these little dots all connected by these little lines of the cell cilia all coming together. But now it's just like an independent term. But it's funny for me because I monitor a lot of the social media, and a lot of the stuff is about, oh, Cilium on GT, like Cilium, like network encryption, blah, blah, blah. And then like, sometimes it's like, the primary cell cilia like does like this and like this involved in this signaling thing. I'm like, oh wow, nice throwback to my previous life.
Okay, so basically you succeeded despite the name and probably not because of it.
It's high in the alphabetical list. I think that's a good thing too. A lot of the times we're ranked pretty high there.
There we go. I forgot to ask you, Microsoft, they also doing their own eBPF thing, right?
I wouldn't say their own thing. They're actually working with the community. So what they're trying to do is to port eBPF to the Windows kernel. And essentially what that would allow you to do is to run eBPF programs on different types of operating systems, right? So eBPF was originally designed for Linux, and that's like where it came out of. But now the power of eBPF is it allows you to add programmability and flexibility into the operating system, right? And that isn't important just for Linux, but it's also really useful on Windows or on other operating systems too. Mm-hmm. And there's actually people using eBPF like in user space too. So there's in actually Solana, they use it a lot for their VM too, right? And so eBPF is useful not just in the Linux kernel. And so what Microsoft is trying to do is to bring eBPF to Windows to allow them to have the same programmability and flexibility, while also ensuring safety and performance in the same way too, right? And we can see that a lot if we're throwing back to the recent CrowdStrike incident, right? The problem there is that there's a lot of different problems there, but part of the problems too, and Brendan Gregg actually wrote a blog about this too, is that there wasn't like this verification that the program was going to be safe for the kernel, right? And so they crashed the kernel. And so with eBPF, you have the verifier in there to check to make sure that they wouldn't, the program wouldn't crash the kernel, right? And so Microsoft is interested in that too, right? Because then you're able to allow third parties have access to your kernel and provide the programmability into it, but still doing it in a way that's safe for your customers, your users, and also for the operating system itself.
That begs the question of just how plug and play can you really make it, given that these are completely different kernels, they have different internals and different ways of doing things. Is the idea to basically be able to take that snake and put it on a Windows version of eBPF and it should run? How interoperable can it really be?
Yeah, so I think the biggest difference between operating systems is like the different hook points that you have in the kernel. It would change where it hooks into the kernel, but ideally like the bytecode is the same. So the program you're actually running is just changing a little bit like where it's hooking into the actual kernel.
So probably Snake doesn't use too many internal hooks, so it should run just fine. That's reassuring. Thanks for that. What's the next big thing? And this is a question that sounds like one, but I actually mean three different ones. What's next for eBPF? What's next for Cilium? And what's next for you?
I think the big thing that's next for eBPF is I think actually what Thomas talked about at the eBPF summit. So eBPF originally began as this like Linux kernel technology as a way to bring innovation, flexibility, programming to the Linux kernel. Now we're seeing to expand to different areas too. So for example, Windows that we talked about, and now since it's all the AI hype right now, expanding to GPUs, DPUs, other things like that, and providing this as a consistent way to reprogramming operating systems level engineering. And if you think about like, why would you want to do that? And why is that actually important right now? And if you look like largely at the trends that we have, like we're starting to generate a lot of data. I think this is like a big trope now about, oh, there's data everywhere. Like we're consuming, we're producing it all the time. Like it's really important for AI models. But I think it actually is becoming a problem when you're actually just like looking at like the physics of the systems. We're producing more data than we can actually consume. So suddenly you can't be like observing your system, streaming that to the cloud, processing it there, and then going back to your system and doing things. Essentially, bringing all the data to the intelligence isn't feasible anymore. We just literally don't physically have enough fiber optics like in the world to be able to do that. And so the question now is, can we actually, instead of bringing the data all the way to the intelligence in the cloud, centralized service like that, how can we bring the intelligence back out to the data so we can make intelligent decisions on the fly as we need them? And I think this is where eBPF is actually going to become a critical piece of computing going forwards, right? Because it's working at the operating system. It has a complete view of whatever's going on in your system, and it's able to reprogram the functionality there, right? Suddenly you're able to add functionality into the operating system and see the data that's coming in from the users and reprogram what's happening on the fly. I think this is going to be really powerful. And so, for example, one of the things that we're doing in Isovalent is you can do TLS parsing in eBPF, right? And then you can see what's in the package and make decisions based on that, right? Rather than having to export the data, doing traffic mirroring and doing those type of things. You can make decisions on the fly in real time and make it very granular about what you want to do. I think that's going to be really exciting because it's going to allow us to solve the problems rather than having to dig a lot more fiber optic cables, being able to shift around way more data. We can instead just reprogram exactly where the data is. I think this is why eBPF is going to be a very large and very powerful technology for really, I would say, a lot of infrastructure technology going forward, and where you're seeing so many companies and projects and products replatforming on top of eBPF is because that's what it allows them to do, is to make decisions exactly where they need to. So that's why I'm excited about eBPF. And I think this is like playing a lot out at what we're doing. So Isovalent actually recently got bought by Cisco, and this vision is in a new project called Hypershield, which is based off of some of what we're doing. And so I think that's what I'm excited about on the eBPF side. Then on the Cilium side, I talked about how Cilium originally began as networking technology and expanded to observability and security. And the two projects I didn't talk about as much as like Hubble, which kind of does the network observability. And that's actually, I would say, people's probably favorite part of Cilium. They're like, wow, this networking is great, but a lot of people do networking, but like this network observability, it is really good because suddenly I can let my app developer teams know what the problem in the network is. And I would say that's people's favorite feature of Cilium once they discover it. But I think what I'm most excited about in Cilium is this other sub-project called Tetragon. And what Tetragon does is security observability and runtime enforcement. So tying back to what I was talking about before, right? So eBPF allows you to have complete introspection of the whole operating system, every single process, every single system call that's happening. And so you're able to see it, have complete visibility of the system, right? And so that's not important just for is something going wrong, but you can also say, is there any malicious actors? Is there any security incidents going on? You can have complete visibility about that. So that's what Tetragon does, is it does security observability. And then also, since when talking about this, like bringing the intelligence to the data, right? You have this data, like there's no point in saying, oh, we have this security incident, let's go export it to our SIM. And then maybe the administrator will get the alert and recognize it between all the other alerts and then go remediate it on the system. No, with Tetragon, instead of what you're doing is you're bringing that intelligence. You're saying, hey, there's a security incident in our system right now. Let's stop that incident where it is in this track. So that's the runtime enforcement. So you can say, this is a malicious actor, we're stopping the malicious actor, right? So bringing that intelligence exactly to where it is rather than like having this much longer cycle. And I think it's a bit interesting. Like I would say some people would argue that Tetragon has the potential to become a bigger project than Cilium itself, right? Because everybody's really concerned about cybersecurity and about what's happening. How do we secure our systems and make sure that we aren't going to be under attack? Because the number of attacks is increasing and growing. And I think Tetragon is going to be a really important part of this story and of the kind of this technology going forwards. So that's why I'm excited from the Cilium side. Yeah. And then the third part of your question, what am I excited about personally? This is actually not technology related. I actually just got a new surfboard yesterday. So I'm really excited to go surfing some more. I also really love biking. I did my first gravel bike packing race. I'm excited to do more of those. And the reason why I'm saying that is because I think people oftentimes get tied up a lot in the technology. And I think technology is like really fun and really interesting, but there's so much more. And I think what's cool is not that just the technology works, but that it enables people to do what they love in their life. And so two things that I love doing is surfing and bike packing, right? And so I think this technology, it's cool to know that, hey, when I book a flight, like this is being run on Cilium, right? Or my system is more secure because I know that like this company is using Tetragon. And it's cool to see a lot of the technologies that I am using in my daily life. I know what I'm doing in my job is enabling me to do these other things that I love to do too. So that's what I'm excited for. Is I think what's cool about working on open source is you have these technologies that are deployed all around the world. And you know that. Here's my Android phone, right? I know eBPF is being used on this phone right now to monitor the network data, right? So this technology I'm used is deployed on billions of devices right now, and it's helping me lead a better life. I think that's what's exciting to me about technology is because by building better building blocks, we can actually create a better world. And so I can go do things that I love to.
Curious timing for surfing the Northern Hemisphere, but you do you, and very good plans there. Before I let you go, Bill, just one last thing. I need to settle a long-standing bet. The bees, as in the insects that are all over the place with eBPF, are they there just because there's the sound B in eBPF, or is there more to the story?
There's been a development of the eBPF logo over time, including at one point, like the F was like the Facebook F, which probably didn't follow a lot of like brand and like legal guidelines. So there's been a development. But yeah, so the kind of like the story behind eBPF is, it is from like the B in the name. And the story behind the actual logo. So it was designed by one of my colleagues at Isovalent, Vadim. He's an awesome graphic designer. And at the first eBPF summit, they had like a contest, like what should we name the actual bee? And it was not Bodie McBoatface. It actually ended up being ED. So the name, the bee mascot for eBPF is EB. So it's E and capital B E E. Yeah, and it's all from the B sound in there.
Okay, so I won this one. Thanks a lot, Bill. Thanks for coming.
Thanks for having me.